This endlessly detailed picture came from something you did in school, solving an equation. Not the answer itself, the border between the answers. With two answers, that border is a clean, smooth line, add a third, and it shatters into this.
Solving an equation made that?
3 answers or more, and a smooth border becomes impossible. To see where this comes from, we first need a place to draw an equation's answers, then a rule that hunts them down. Ordinary numbers, like 3 or -2, sit on a line. But many equations have answers that need a second direction, called the imaginary part. A complex number, written a plus b times I, is just a point on a flat plane. A goes left to right, b goes up and down.
So the answers are points on a 2D plane?
Exactly, and an equation like z to the 5th equals 1 simply has several of these points as its answers. Our whole picture is just that plane, colored in. Newton's method is a simple repeated rule. From any starting point, it uses the local slope, a line just touching the curve, to jump to a better guess, again and again. So color that starting point by whichever answer it finally reaches.
Every point on the plane gets a color?
Almost every ordinary point does, and the plane splits into colored territories, one per answer. The real question is what happens at the borders between them. With one answer, every point reaches it, so the plane is one flat color, with no border at all. With two answers, a quadratic, the plane splits cleanly, with a single smooth line. But go to 3 answers, and watch that border.
Whoa, it suddenly has endless tiny detail.
1, 2, 3 answers, and the border goes from nothing, to a line, to a fractal. So what does fractal actually mean? A fractal is a shape that keeps revealing new detail at smaller and smaller scales. It never settles into one smooth curve. Watch, as we dive into the border, fresh buds and curling filaments keep appearing.
However deep we go, it never smooths out.
Fresh detail at every magnification, that is a fractal. But why does a third answer wreck the smooth line? Think of a point sitting right on a border. To be on a border, it must sit between answers it could fall toward. And here's the twist, every tiny patch of this border, however small, touches all 3 territories at once.
All 3 are always right there together?
Yes, that's called the Wada property, and no smooth curve can do it, so the border is forced to crinkle without end. And this isn't special to one equation, or even to Newton's method. Many Newton-like root finders do the same, sorting starting points among 3 or more answers, they leave a fractal border. A 4th-degree equation, a 5th, even sign with endlessly many answers, each one fractal, each with its own pattern.
So a different equation or method just changes the shape, not the fractalness?
3 or more answers, chased by a Newton-style rule, and a fractal border is the typical result. Mathematicians even have a name for this border, a Julia set. And it's not just that it looks fractal, it's a theorem. Right on the border, the rule turns hypersensitive, a hair's difference can send you to a different answer. Mathematicians can prove that, for Newton's method on a polynomial with 3 or more distinct answers, this border is never a smooth curve.
So the fractal is provable, not a coincidence?
A plain question, solve this equation, hides a border whose roughness is a theorem. So picture the territories of an equation's answers on the plane. Where 2 of them meet, a clean line, where 3 or more do, a coastline with no end.
So one extra answer flips the whole thing.
That's the surprise, a third answer changes what kind of border is even mathematically possible.